Good day, grade 11s. Once again, we are back together. Your favorite uncle is once again with you. All right, so today we are going to be looking at the mathematics paper 2 from 2015. I heard someone say that we shouldn't look at old question papers, but remember, maths is maths. And at the end of the day, all the other sections that are here are still relevant in our syllabus at the moment. So let's dive into it. I hope that you enjoy it. Please, if you haven't subscribed, just make sure you do the right thing. And of course, if you need to know about our other services that we provide, all the information rather that you need is on the description of this video. All right, so let's jump right into it. With question 1. So they say the table below shows the weight to the nearest kilogram of each of the 27 participants in a weight loss program. Right, so we're given all of that information. And the first thing that they ask us is calculate the range of the data. Now, what I like about this data is that they've already placed it in ascending order, starting with the smallest value to the biggest value. So it would be easy for us to calculate the range. All we do is we take the maximum value minus the minimum value. All right, so we're going to say maximum value is 156 minus our minimum value, which is 56, right? And so it means that our range of this data is simply 100. And then they say to us, write down the mode of the data, right? So remember, the mode is the value that appears the most, right? So in this case, we're going to say our mode, which value appears the most there. That's definitely 71. So that means that the mode is simply equal to 71. Right, and they want us to find out or to determine the median. So remember that the median is the middlemost value. So we've got 27, our data rather, we've got 27 participants, right? And as a result, it means that the number, right, of data sets that you've got, or in this case, the data set consists of 27 participants. And so what is the middlemost value, right? What is the in the middle of 27? So that would be, it means we'd have 13 on this side. We'd have another 13 on this side, which makes 26. And so the middlemost value will be the 14th value, right? So if you think about it, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14. So our 14th value is the one that is the middlemost value. And so it means that our median is 93, right? So that is it. And they want us to determine the interquartile range. Now, so remember, now that I've got my first data set in this case, right? My first half of the data. So what should be in the middle? Remember, we've got 13 on each side, right? So what is halfway in this case? So which means, if you think about it, so you might have 6 on this side and another 6 on this side. So 6 and 6 would give us 12. So in the middle here, the 7th value, right? So let's look at it again. So that's 1, 2, 3, 4, 5, 6, 7. So this is Q1, right? So this is in the middle of the first half. So that's going to be Q1. And now you go to the second half of your data. Perhaps let's use another color there, right? And again, right, you've got, in this case, 13 values that you've got. So in this case, it means that I'm going to again take the 7th from the one from my second half. So that's 1, 2, 3, 4, 5, 6, 7. So my Q3, right, is going to be that is 127. So to calculate interquartile range, right, I'll simply say that's Q3 minus Q1. And so that's 127. Okay, I don't have enough space there. So that's going to be Q3 minus Q1. I'm just trying to squeeze in. right? So that's 127 minus, in this case, we've got 82, right? So let's see what we will get there. So that's 127 minus 82, and we get 45. So which means our IQR is 45. Right, now they say to us, determine or use the information, right, provided in the answer book to draw a box and whisker diagram for the above data. Now, ladies and gents, remember, so the first thing we're going to do is to draw a number line, okay? And on my number line, I'm going to start with my minimum value, which is 56, right? So let me, just for the sake of trying to make this a little bit simpler, and I know that it's not really going to be the most accurate, so I'm going to actually make my data in tens. So let's start with 56, 66, 76, 86, 96, 106, right? And that's 116. That's going to be 126, 136, 146, as well as 156. That would be the last one, right? Actually, that should be right there. All right, so let's just try and keep to the same scale, right? So that's going to be 156 over there. Right, now ladies and gents, let's try and populate our data as much as possible. And I know I haven't really drawn it to an accurate scale. What you will try to do is actually follow a scale that is really user-friendly, right? Okay, so my minimum value in this case will be 56. So I'm gonna plot that there on my number line, right? And my maximum value is at 156. All right, now we said our Q1, right? You remember that we had our Q1 that we said is at 82, right? So our Q1 is at 82. So 82 should be somewhere here. That's our Q1 value. And we've got Q3 at 127. Okay, so it should be somewhere here. So this is our Q3 value. All right, and in this case, all that we are going to try and do, okay, so that forms our box. All right, so there we are. And in this case, it means these are going to be our whiskers. Right, so there we are. So there is our box and whisker plot. Right, now, remember, we need to also indicate what our median is. So our median is at 93. Okay, so our median is somewhere over there. So that is, okay, so maybe let's just put it over here. Okay, so this is going to be our minimum value. Okay, so that's minimum. And this is going to be Q1 over here. This is going to be Q3. This is Q2, also referred to as the median. Okay, so in this case, we can actually comment about the skewness of the data. I mean, looking at our box and whisker plot. Now, let's go to the next question. They say to us, determine the standard deviation of the data. So what we are going to do, ladies and gents, is that we're going to put this data now in our calculator, right? So remember, you go to mode, you choose stat, right? And in my case, I'm going to make sure that I choose the one variable calculation, right? So we're going to now put in all our data in this case. So that's 56. Okay, remember to put an equal to, that's 68, that's the second one, that's 69, that's 71. I know this is going to be very tedious, but we need to put in all the data that is given to us. So that's 82, that's 84. Okay, remember to press equal to every time you put a value. Right, the next one is 85. Okay, so we've got 88, we've got 89, we've got 90, we've got 92, we've got 93, okay, 94. Right, and if you don't want to watch me putting in all of this data, you can actually just fast forward, okay, to the part where I get the answer. Right, so we've got 97 and we've got 99. Okay, so now let's go to the 102. Right, so we've got 102, we've got 103, we've got 127, we've got 128, we've got 134, 135, 137, 144, and the last one, which is 156. Now that is all my data. In this case, what I'm simply going to do, because now we want the answer, you say shift and you go to number 1 where it says stat, right? And remember, I'm looking for the one variable calculation. Okay, so in this case, okay, so shift, remember I am looking for the calculation. Now, this tells me that my mean in this case would be 2,662 over 27, right? We can calculate what that gives me. And that shows me that I've got all the 27 values, right? So there it is. I've got the standard deviation. So my standard deviation, we're going to actually calculate this. It is 2 multiplied by square root of 121,679, all of that divided by 27. Let's find out what that gives us. Right, so we've got that as our standard deviation. Look at that, we've got our mean, which is 2662 over 27. So our mean is 2,662 over 27, right? And there is our standard deviation. Now let's quickly have a look at it. So now we're going to, okay, let me just clear all of that. So this is 2 multiplied by 121,679, okay, and this is divided by 27. All right, and I get a value there, which is 25.84. So that's 25.84. That is my standard deviation, ladies and gents. Right, and please, you can verify it in your calculators as well. Okay, if you're not sure about how to calculate this, please go and watch my stats video. Even though it might be written grade 12, it actually is relevant to grade 11. Okay, right, now that is our standard deviation. Okay, 25.84. Now they say the person weighing 127 kilogram states that she weighs more than one standard deviation above the mean, right? Do you agree with this person? Motivate your answer with the calculations. Right, so now let's find out. For 1.7, what we need to find out is, well, what is one standard deviation above the mean? So we're going to take the mean plus the standard deviation, right? So remember we said that was the mean 2,662, okay, and divide that by 27. So our mean is 98.59, okay? And our standard deviation, you remember, right? We said our standard deviation was 25.84, right? And I get a value, so that's 25.84. I get a value which is 124.43, right? And I know that I rounded off a bit, So I get a value which is 125.43. This is one standard deviation above the mean. So now remember what the person said, right? The person weighing 127 kilograms states that she weighs more than one standard deviation. Well, my one standard deviation above the mean is 124.43, and this person weighs 127 kilograms. So they say, do you agree with this person? I absolutely agree. So yes, we agree. Right? Yes, I agree. Right? And in this case, they say motivate your answer with the calculations. And that's exactly the calculation that I have. And you note that 127 is definitely greater than 124.43. And ladies and gents, that is really how the cookie crumbles. In this case, just a quick reminder that our mean in this case was was 98, right? So if you note there, right, your median, where's our median? Our median was at 93, yet our mean is at 98, right? So our mean would have been over here. Let's just say 96, 98. So that would have been a mean. So in this case, of course, we've got data that is somewhat skewed to the right, isn't it? So as a result, in this case, our data is skewed. So ladies and gents, that is really how we are going to end this, and we're going to look at the next question. I hope that you were able to understand. Let's go to the next question. 2, they say the table below shows the weight in grams that each of the participants in a weight loss program lost in total over the first 4 weeks. Right, now where they give us that data there, and they give us the frequency. All right, so remember, in this case, we, when you are given the frequency, we probably might have to draw the ogive or the ogive, right? So they say to us, estimate the weight loss in grams of the average weight loss in grams of the participants over the first 4 weeks. Now, ladies and gents, when you have data, this is bivariate data, right? So we've got two forms of data in this case. Right, so what we're going to do is, firstly, we're going to find the middle value there. In this case, the midpoint of your range, right? So if we look at this, we are given there, first of all, between 1,000 and 1,500, right? What is the midpoint between those 2 points? That's going to be 1,250. This is going to be between 1,005 and 2,000. That's going to be 1,750. You can do that calculation by simply saying 1,000 plus 1,5, right? And you divide that by 2, right? Okay, so in this case, this is going to be 2,250. This is going to be 2,750. I'm sure you can see 3,250. This is 3,750, 4,250, and 4,750. Right, so these are all my midpoints of the values there, right? And then I want you to note we've got our frequency values there. And what we are simply going to do, ladies and gents, is that we are just going to multiply those midpoints by the frequency, and we divide by the total number of values. Now, what I always advise is that you always calculate your cumulative frequency on the side, right? So without even you being asked, that may be somewhat helpful for you. Okay, so I'm just going to take that. So now I'm just going to say 2 here, right? And then you say 2 plus 3 will give me 5, right? 5 plus the 3 will give me 8. 8 plus the 4 will give me 12, okay? And 12 plus the 5 will give me 17. 17 plus the 7 will give me 24. 24 plus the 2 will give me 26. And 26 plus the 1 will give me 27. Right, and that's my cumulative frequency values, right? Okay, now let's calculate the estimated mean. So how you calculate the estimated mean is that I'm going to take my midpoints, right, of my data and multiply it by the frequency value, right? So I'm going to say, right, in this case, okay, I'm just trying to remove this. So I'm going to say 1250, that's the first one, that's the midpoint, multiplied by 2 plus 1750 multiplied by 3. This is the value that I'm referring to. And the next one, plus, that's 2250 multiplied by 3 again, right? So that's the value. And I add 2750 multiplied by 4, that's the value, plus the 3250, okay, multiplied by the 5, plus we've got 3750 multiplied by the 7, plus I've got the, okay, so we've used this one, 4250, okay, multiplied by the 2 again, plus the 4750 multiplied by the 1. All right, so we have used all of those values, right? Now I take the sum of all of that and I divide by the total number, right? Or in this case, my cumulative frequency value. What you could have also done, this value here must be the same as the value here. When I add all of these values up, right, it must give me 27, which should be the same as the last value of my cumulative frequency. So I'm going to divide this by 27, okay, and I get 3009.25. Okay, so my estimated mean would be 3009.27. That is the estimated mean, and that's how you calculate it. All right, now they say to us, draw an ogive, right? Calculate the cumulative frequency graph of the data on the grid provided. Unfortunately, I don't have that grid, but I'm going to try and, okay, let's try and draw ourselves a cumulative frequency graph there. Okay, now what I'm going to do is I'm going to start. Now remember, what you are going to do is when you draw the ogive, you are going to take the values, the upper bounds in this case. All right, so what we're going to do is I'm going to have a value 1500 at 2000. I'm going to have another one at 2500, and so on and so forth. Right, so but before I even get to 1500, remember that's where we start. Okay, so I'm going to say, right, this is 1500, okay, and this would be at 2000. Okay, I'm going to have, I am going to have, right, so they will increase by, all right, I keep erasing for some reason. Okay, so 1500, I've got 2000, I've got 2500, I have 3000, okay, and I've got 3500. I think that was the, okay, up until 5000. Okay, and apologies, I'm gonna have to just write over these words, right? So that's 4,000. Okay, so I won't be able to fit all of that in there. Okay, so I'm gonna have to shift my graph a little bit. Okay, let's just draw the graph over here. And so we said that's 1,005. That's 2. That's 2,005. That's 3. That's 3,500. That's 4,000. 4,500. Okay, let's extend this a little bit. Okay, all right, so there we go. Okay, it would have been much easier, obviously, if we had, the graph that was given to us. Now remember, ladies and gents, I am going to take this value over here together with the value of the cumulative frequency. So I can see I start from 2 and all the way to 27. So let me just increase my values here in 2s. So that's 2, 4, 6, 8, that's 10, 12, 14, 16, 18, and 20, 22, 24, 26, 28. Now, ladies and gents, I know that my graph is really not going to be the best. Okay, that's 2, 4, 6, that's 8, that's 10, 12, 14, 16, 18, and 20. Okay, I've got 22, 24, 26, 28. All right, now let's start with our very first one. Okay, now at 1,005, right, the first value that I have is 2. Okay, so at 1,005, the value I have is 2 over there, right? And then at 2,000, the value is 5. So at 2,000, okay, my value there would be 5. There it is. And at 2005, my value is 8. Okay, so there's 8 over there. Okay, and the next one, at 3,000, my value is 12. Okay, there it is. And at 3,005, my value is 17. So there is 17 over there. Okay, and that's the value at 3,005. So there it is over there. Right, and then at 4,000, the value is 24. Okay, so there's 24 over there. Okay, there is my point. 4,500, I've got 26. And at 4,500, I've got 26. And finally at 5,000, I've got 27. All right. Now, of course, what I always do is just to extend it so that my graph starts at 0. Okay. And our S-curve would look something like this. Okay. Right. Of course, as I did say that it would look much better if it's not a straight line graph. So usually your cumulative frequency graph looks something like an S-curve. Right, so in this case, of course, you're going to try your best to try and fit it into the graph that is given to you. Right, so now we've drawn up cumulative frequency. They say to us the weight loss guarantees a loss of 800 grams per week if a person follows the program without cheating, right? They say, hence, determine how many participants had an average weight loss of 800 grams or more per week over the first 4 weeks. Now note, this is 800 grams per week. So meaning over the period of 4 weeks, what would it be? Right, so I'm going to take 800 grams multiplied by the 4 weeks. Okay, so let's multiply that. So 800 multiplied by 4, that gives me 3,200. Okay, so now what you would do, ladies and gents, is you would go to your graph and find out where is my average loss of 3,200. So I'm going to estimate it over there, right? So that's 3,000, between 3,200 and 3,500 rather, 3,000 and 3,500. So just slightly to the left, that would be 3,200. So let's estimate it over there. So there is the value. I'm just going to shift it just slightly to the left again. Okay, so all right, so there again I made an error. Right, so let's go. So there it is at 3,200. Now what's my corresponding y value in that case? So if I take my ruler, and in my ruler, let's find a value that corresponds to that. That looks like somewhere at 15, right? And of course, my graph is not really too accurate, but you can check. Oh, oops. It's made it at 16, but you can see, ladies and gents, it's actually just below that value there. So I would say at 15, shall we? Right? I keep making this error. Right, so it would be at 15. So in this case, I'm going to say, well, anyone from 15 upwards is above that 3,200. So this value here would be 3,200. So I'm going to say anyone that is from 15 above rather is actually above the 3,200 that they were talking about. So how many people would that be, right? So I'm going to say, well, that's going to be 27. That's the total number of people minus 15, right? And in that case, what would that give me? So that's 27 minus the 15. That would give us 12. And of course, ladies and gents, my value might be slightly different because my graph is really not the best in terms of accuracy. You can actually check that again and see if you get a similar value. If you do have that table, please do use it so that your graph can be even more accurate. So which means anyone between this point and here, right, that 15 mark, then we know that they have actually exceeded that 3,200. Ladies and gents, this is where we're going to leave this, and I hope that you are able to understand. And of course, if you are still having a bit of a challenge in drawing these type of graphs, again, I'm going to send you to my stats videos, right, where you are going to see how to apply this more effectively. Let's go to the next question. Let's look at question 3. They say in the diagram, we've got A, which is -2 and 3, C, which is 10 and 15, D, and which is 5 and -1 are the vertices of triangle ACD. Right? They say that CA intersects the y-axis and F, and CA produced cuts the x-axis in G. Right, and please note that when they say to us it's produced, they simply mean it is a straight line, it makes a straight line, right? So they say to us the straight line DE is drawn parallel to CA, and CFO is equal to alpha. Right, now let's quickly have a look at it. So they said to us, calculate the gradient of the line AC. Okay, so if we look at AC there, so I'm going to just quickly change my color. So the gradient of the line AC, right? So we're going to say y2 minus y1 divided by x2 minus x1. So in this case, because we're looking at AC, I'm going to take C as my second point. So that's going to be 11, that's the y value, minus y1, which is 3, divided by, again, we're going to start there at C, that's 10 minus a negative 2. So this is 11 minus 3, that would give us 8, divided by 10 plus 2, which is 12. Okay, so please note if I am going to simplify it, right? Both are factors of 4, or rather 4 is a factor in this case in both. In this case, so we're saying 8 divided by 4, right, will give us 2, and 12 divided by 4 will give us 3 rather. So the answer there is 2/3. Now they say determine the equation of the line DE. Now note in this case that the gradient of DE would be equal to the gradient of the line AC. And why is that? Because in this case they are parallel. So remember that every time we've got parallel lines, that their gradients should be equal. Right, so in this case we've got 2/3. So the equation should simply be y is equal to 2/3x plus c. But now how do we get the c value? We're going to just substitute one of the points that the line DE passes through, and that's the point D. So we know that when y is -1, right, x is 5. And so in this case, I'm simply going to say, well, that's 2/3 multiplied by 5, that will be 10/3. But if we take it to the other side, it becomes -10/3. So I'm going to have -1, okay, minus the 10/3. Okay, so I get minus 13/3. So that's the C value. So C is -13/3. Now what is the equation? The equation is y is equal to 2/3x minus 13/3. Right, and so that is the equation of the line DE. Right, now they say calculate the size of angle alpha. All right, now ladies and gents, what I'm going to do is I'm going to look into triangle C, what is that? No, actually FGO. Right, now if we look at that angle there, so how can I find the size of that angle? Now ladies and gents, note that in that triangle, we always say the exterior angle of a triangle, right? So alpha is the exterior angle of that triangle. So we always say that the exterior angle of a triangle is equal to the sum of the opposite interior angle. Now we already know that angle O or FOG is 90 degrees, right? So this angle is 90. Because in this case it is your axis, right? And then we now need to find this angle over here, which is FGO. Now, how can I find angle FGO? So we know that the tan, right, of angle FGO is equal to the gradient of the line FG, or which is FC. So that's the gradient of the line FC. We just found it, right? The line AC rather, not FC. The line AC, I'm still writing FC for some reason. Right, so that's the line FC. So now, which means angle FGO would be the arc-tan, the inverse tan of the gradient, which is 2 over 3. Right, so let's find out what that is. So that's shift 10 of 2 over, okay, so let's delete that. So that's shift 10 of 2 over 3, right? So there it is. That's 33.69. So that's 33.69. So that's the size of that angle, 33.69. And so what it means is that angle alpha will be equal to, right? We said alpha is angle G or FGO plus angle O, which is in this case the intersection of our axes. So that is going to be 90 or 33.69 plus 90. Right, so in this case, this will give us 123.69 degrees. And that's the size of angle alpha. So we said this is 123.69. Right, please verify that, ladies and gents, and please remember your theorem when it comes to angles. I should have said here exterior angles on a triangle. So this is exterior angles of a triangle. Right, now let's go to the next question. Now they say B is a point in the first quadrant such that A, B, D, E in that order form a rectangle, right? They want us to calculate giving reasons, the coordinates of M, the midpoint of BE. Now, let's take our line BE. Okay, so firstly, they said ABDE. Okay, ABDE. All right. Okay, so I want to just find that line there. So ABDE, they said in that order must form a rectangle. And remember that they said B is a point in the first quadrant. Okay, so B must be in the first quadrant. Okay, so if we say B is over there, right? So we know that it must actually form a rectangle. Okay, so there it is over there. All right, so there's our rectangle. I know that it's not really in terms of the best. That is really not the best, right? Now they told us that actually this forms a rectangle, right? And what do we know about the properties of a rectangle? Now they said to us we must find the coordinates of M, which is the midpoint of BE, right? So if you look at BE, right, so there it is a diagonal. I know that it's not really too accurate there, but what do we know about the diagonals of a rectangle? We know that they bisect each other, so which means that midpoint would actually be the midpoint of AD as well. So we might as well just look for the midpoint. So there's M over there. So if we look at M, the coordinates of M are going to be, right, let's start with the x coordinates. That's going to be -2 plus 5 divided by 2. So I'm taking the x coordinates at A, x coordinates at D, right, divided by 2. And then again for the y, what are we going to have? We're going to have y coordinates at A, which is 3, plus another y coordinate at D, okay, and this is divided by 2. Right, so then what do we get? We've got -2 2 plus 5, which is 3. So that's 3 over 2. And we've got another one there, which is 3 minus 1, which is 2 over 2, which is 1. All right, so that is our coordinates at M, right? So M should be the point 3 over 2 and 1. Okay, right, and now they say to us the length of diagonal BE, right? Now note yet again, what do we know about the diagonals of a rectangle? We know that they are also equal. So BE should actually be equal to AD. So we can actually find, okay, so BE is equal to AD. And we can say that these are the diagonals of a rectangle. All right. Now, let's do this. So we know we've got, okay, let's find BE, is it? Now let's find AD. So AD, that would be the square root of, now x2 minus x1, or rather let's say xd minus xa squared plus yd minus ya squared. So let's substitute the values there that we have. We know that this is going to be the x value at d, that's 5. So this is going to be 5 minus a negative 2, which is 5 plus 2 squared. And what about our y values? That's negative 1 minus 3. So that's minus 1 minus 3 all squared. And all that we are going to be left with, okay, let's just put that in our calculator. Right, so we've got square root of 7. Okay, so that's 7 squared plus, we've got negative 4, but remember that negative squared is actually a positive, so we might as well just say plus 4 squared. Okay, we get square root of 65. All right, units. So which means the value of BE is equal to AD, and so both of them would have the square root of 65. All right, ladies and gents, I'm going to leave it in said form. And really, that is how we're going to answer this question. I really hope that in the midst of all of this, you are able to understand. Let's go on to the next question, which is question 4. On to question number 4, they say to us in the diagram we've got a straight line which is SP, is drawn having S and P as its x and y intercepts respectively. They say the equation SP is x plus ay minus a equal to 0, where a is greater than 0. They say if it is given that OS is equal to 3OP, right, they say the straight line RT is drawn with R on SP and RT perpendicular to PS, right? So we can see that there, that these two are perpendicular to each other. All right, and what else did they tell us? So remember, we know that the size of OS is 3 times the size of OP, okay? And yeah, so let's they give us the point T there. Right, so let's start with the first one. They say to us calculate the coordinates of P. Now P is the y-intercept of the line SP, right? So firstly, let's start by let's try and make this into standard form. Y is equals to mx plus c. Right, so we're going to say this is going to be x plus, or rather let's take ay and make it the subject of the formula. This is going to be minus x plus a, right? So if we take all of that, we leave ay, we take everything else to the other side. So we've got minus x plus a. And if we divide both sides by a, so that cancels with that. So we are left with minus x over a plus 1. Now please, I want you to note, which means we divided this by a, we divided that by a. We're left with minus x over a. Or we can write it as y is equals to minus 1 over a x, right, plus 1. So already, ladies and gents, that tells us that the point P, or the y-intercept, right? This always gives us the y-intercept. When you say y is equals to mx plus c, the c value is a y-intercept, and as a result, the c value will be equal to 1. So we know the point P will be actually where x is 0 and y is 1. So that also tells us that distance OP should be equal to 1 unit, right? Because it's from the origin all the way till where y is equal to 1. So P is 0 and 1. Okay, so they say to us calculate the value of A. Now, we already have the equation in standard form, right? Now, what I'm going to do, ladies and gents, is that I am going to actually just put in this value. So remember, they said to us that OS is 3 times OP. So if OP is 1 unit, okay, notice it's from y is 0 to y is 1. So this guy should actually be 3 times that, which is 3 units. Now remember, it is from the origin, it's from 0. So therefore the point S must have the coordinates 3 and 0, since it is on the x-axis, right? So I know 1 point. Okay, so I can now say for that question, we know 1 point, which is y is equal to, now this is supposed to be negative. That's negative 1 over a x plus 1. So we're going to substitute the point 0 and 3 on it. We know that when y is 0, okay, x would be equal to, so that's minus 1 over a. X would be equal to 3 plus 1. Okay, so let's try and do our gymnastics as much as possible. So that means negative 1 is negative 3 over a, right? And of course, if I multiply, cross multiply on either side, so the negative and the negative cancel out. So a times 1 is a, and 3 times 1 will give me 3. So the value of a will be equal to 3. Remember, we substituted the coordinates of S, which is 3 and 0. Right, so we found out that a is equal to 3. Right, now ladies and gents, the next question, they say determine the equation RT in the form y is equal to mx plus c, right? If it is given that a is equal to 3. Now, we found out that a is equal to 3, right? We are looking for the equation of RT, right? Now, remember, RT is perpendicular to SP, right? So that means that their gradients, right? Let's say the gradient, okay, so the gradient of SP multiplied by the gradient of RT equal to negative 1, right? So in this case, we know that RT is perpendicular to PS, and that's given, right? So therefore, the gradient of RT, now that we found that A is 3, right? So we know that the gradient of RT, so which means the gradient of that line SP would be negative 1 over 3, right? So remember, which means that the line SP would be minus 1 over 3 x plus 1. So which means now the gradient of RT should be actually equal to 3. So remember that when lines are perpendicular, the product of their gradients should give us -1. And what that means is that you'll take the inverse of the other gradient and you'll change the sign of it. Right, so we've got a point that we know there. Actually, we know what already the the y-intercept is. So therefore, it means that the equation of RT would be y is equal to 3x, right? And there's our y-intercept, right, where x is equal to 0. So this is -5 and 2/3. I hope that makes sense, guys. You could have substituted the point t, where x is 0 and y is -5 and 2/3. You'll see that you get to exactly the same thing. So now we've got y is equal to 3x minus 5 and 2/3. Actually, let's write that. So that's 3 times 5, which is 15, right, plus 2. So this is going to be -17/3. Okay, right. Now they say to us, calculate the coordinates of R, right, the point where PS and TR meet. Now notice we've got the equation of P, or rather of PS, right? And we've got the equation of RT now, or TR. Right, so we are going to just simply equate the two. So for 4.4, I'm going to say 3x minus 17/3 is equal to -1/3x plus 1. Okay, let's try to work through that. So we've got 3x plus 1/3x, right? So that will give us 10/3x. So 3 plus 1/3 will give us 10/3. And we've got, if we take that 17/3, it becomes positive, right? So this becomes 1 plus 17/3. This will give us 20/3. Okay, right. Now if we can take down the denominator since they are the same. So 10x is equal to 20, and which means 10x equal to 20. Sorry, if I divide by 10 on either side, so x would be equal to 2. So they intersect at the point where x is equal to 2, but remember, we're looking for the coordinates of R. So what I'm going to do is I am going to find the other point at the y value, and we can do this by substituting in any of the two equations. So y is equal to -1/3 times 2 plus 1. Okay, so that's -2/3, right, plus 3/3, so that will give us 1/3. Right, so in this case, what do you have? You've got the coordinates of R as 2 and 1/3. Right, there was nothing wrong if you decided to substitute it there. You would get exactly the same thing. Right, and now they say to us, calculate the area of triangle PRT if it is given that R is 2 and 1/3. Now note, they are already giving you that R is 2 and 1/3. Now, how do we get the area of a triangle? So notice, if we can treat this as our base, right, you can see that therefore this guy here, which is RT, will be our perpendicular height since they're both at 90 degrees to each other. Right, so if we can find the size of our PR and as well as the size of RT, right, so I hope that you won't mind. I'm just going to try and remove some of the things. Yeah, let's see. Let me get some of the things out so that we can actually make a calculation. So let's find the size of PR, right? So that's PR. This is equal to the square root of, so this is going to be XP minus XR squared plus YP minus YR squared, and this would give me the square root of, right, so that's X, so this is going to be 2 minus 0, so 2 minus 0 squared, plus our Y values are 1 over 3 minus 1, so that's 1 over 3 minus 1 squared. So what is the value of PR? That's going to be 4 plus, right, that's going to be 2 over 3, negative 2 over 3. So this is going to be square root of 4 plus, now this is going to give us 4 over 9. Okay, so let's try and get that quickly. 4 plus 4 over 9, right, so that's 40 over 9. If we take the square root of that answer, okay, that gives us 2 square root of 10 over 3. Right, now ladies and gents, what we are going to do, all right, so let me do this. We found the value of PR, right, which is that line over there. Now I'm going to look for the value of RT. Okay, so I am not going to actually waste time on that. That's going to be 2 minus 0. Again, that's 2 squared plus. Now we've got 1 over 3 minus 17 over 3. So we've got 1 over 3 minus 17 over 3. In this case, that gives us minus 16 over 3 squared. Right, so again, I'm not going to waste much time there. I'm going to say 4 plus. Okay, so this is going to be negative 16 over 3, or we can just simply say 16 over 3, right? And that is, okay, I'm gonna remove that squared. Okay, and all right, it tells me that there is an error that I have there. Let's see. Okay, so this is 4 plus 16 over 3. Okay, and we square that. All right. Okay, so it seems like I keep doing something that's incorrect there. Okay, so let me just take that. So that's 16, right? So that's 16 squared, which will give us 16 squared. Okay, let's do this. 16 squared, that's 256 over 9. So let's just add that up. That's 4 plus 256 over 9. All right, I get a square root. 2 root 73 over 3. Please just verify that for me. Right. Now, remember, area of a triangle is always going to be half base multiplied by the perpendicular height. Okay, so I'm going to say, well, our base in this case is PR, right? So that's half of PR multiplied by the perpendicular height would be RT. All right, now, ladies and gents, I don't have as much space here, so I'm just going to write it over there. So my PR value, right, we've got 2 square root of 10 over 3 multiplied by 2 root 73 over 3. Right, so let's find the area of that triangle. So that's 1 over 2 multiplied by, okay, that's 2 square root of 10 over 3 multiplied by 2 square root of 73. Actually, I should have done this. Multiplied by, let's make the fraction. So that's 2 square root of 73 divided by 3. Right, so I get a value of 6.004. We might as well just say this is going to be 6 units squared. Okay, so that's 6 square units. That is the area of that triangle. Right, I hope that you got that, ladies and gents, and let's go to the very last one, right? They say calculate, giving reasons, the radius of a circle passing through PRT. So if I look at a circle that would be passing through PRT, all right, now this would be a circle, right? Now I want you to note, how would I know what is the radius? That's what they asked us, okay, of that circle. So if I look at the line PR, rather PT, okay, in this case, this would be my angle at semicircle with rather the angle P. Now, if you notice that gives us 90 degrees. So this makes the line PT a diameter, right? I know that my circle is not circling, right? But in this case, it means that my line PT is a diameter. And what am I using there? Angles at semicircle. Remember that a line that is subtended by a diameter is, in this case, forms a 90 degrees. Okay, right. So in this, we're just simply saying an angle rather that is subtended by a diameter is equal to 90 degrees. That's angles at semicircle. So let's find the length PT, right? We already know that the length there is, rather the x values are 0. So PT would be the y value at P minus y value at T. So let's say P is 1 minus a negative 5 and 2 over 3. Okay, and that's 1 plus 5 and 2 over 3. Remember I said to you that's 17 over 3. Okay, and that gives us 20 over 3. So that's the length of PT. But remember, we need to also divide that by 2 because we're not looking for the diameter, but we're looking for the radius. So the radius of that circle would be equal to 20 over 3 divided by 2, right? So we find the answer and we divide that by 2 and we get 10 over 3. Okay, so the radius would be 10 over 3 units, and I hope that you got that, ladies and gents. Remember that, if we don't know our Euclidean geometry at this stage, it would be really helpful for you to know that by now. Okay, right, let's go on to the next question, all right, which is question 5. Start with question number 5. So they say in the diagram below we've got P, which is x and 24, right, which is a point such that OP, so meaning that the length of this line here is 25, okay, and they say ROP is beta, where beta is an obtuse angle, right? So they say calculate the value of x. Now notice, ladies and gents, that we can actually make this into a triangle, if you look at it. So we know that the value of the y value is 24. Okay. And we know that the r value, meaning the distance of this line, is 25 as it's given. Okay. And so all that we are left with is to know what the x value is. Okay. Now what we're going to simply do is just use the Pythagorean theorem. Okay, so we know that x squared plus y squared is equal to r squared. So we're looking for x, so x squared is equal to r squared minus y squared. That's going to be 25 squared minus 24 squared, right? And so this will give us 25 squared minus 24 squared. That gives us 49, and the square root of 49 is actually, so square root of 49, that would be plus or minus 7, right? But in this case, notice this is in the second quadrant, so that means that x would be negative 7. Now they say to us, determine the value of each of the following without using a calculator. Right, so now we're going to look for the sine of beta. Now remember that sine is, in this case, y over r, okay? Or you can say opposite over hypotenuse. So y over r, that is our y value is 24, and our r value is 25, and that's a sine of beta. Now using the reduction formula, ladies and gents, cos of 180 minus beta. Now remember, how is cos in the second quadrant? Well, cos is negative in the second quadrant. So in fact, we are looking for minus the cos of beta, right? So now that's negative. Now remember, cos is x over r. So our x is, okay, so let's say minus x over r. So that's minus. Remember that our x value is negative 7, okay, over r, which is 25. So that means that this is going to be just negative times negative is positive. So our answer is going to be 7, positive 7 over 25. They say 10 of 360 minus beta, right? So we're going to say, well, rather 10 of minus beta. So what we are going to do, okay, going on to the next one, we're going to say 10 of 360. So every time you've got a negative angle, you just simply add 360. So that makes it 360 minus beta. Now once we've gone 360, and by the way, anytime you add or subtract 360, you're back to the same point, right? You are just adding a revolution and it takes you back to the same point. So we haven't changed anything. So 360 minus, that's in the fourth quadrant, right? Please note, if you have not watched my videos on this section, please do so urgently. Okay, even though they might say grade 12, please note that they are also relevant for grade 11, right? So that's 10 of 360 minus. That will give us, 10 is negative in the fourth quadrant. That's negative 10 of beta. So that's minus. Now note in this case, what is 10, right? That's y over x. So y is 27, x is negative 7. So that would be minus 24, or 24 over negative 7, just to be technical, right? Remember again, negative times a negative is a positive. So we end up with an answer of 24 over 7. Okay, that is our final answer. All right, ladies and gents, right, as we're moving right along to the next one, they say T is a point on OP such that OT is equal to 15, right? Determine the coordinates of T without the use of a calculator. Now, okay, So let's see. So OP. So there is T over there. Right? So they are simply telling us that OT is 15 units. So now we've changed the R value. All right? And they want us to determine the coordinates of T. Now, I want you to note that the angle simply stays the same, ladies and gents. All right? And so what it means is that you are now introducing just a line that is here. What's going to change? Well, our R value has changed, and most certainly it's going to change our X and Y values, right? So what we can do to get the X and the Y value, we can either use ratio and proportion, right? We've got lines that are parallel there, okay? Alternatively, we can say, well, because the angle is still the same, right? The sine, okay? So sine of beta is equal to, I'm going to use X over R, right? So in the previous one, it was -7 over 25. Y over R, rather, 24 over 25. So 24 over 25. But this is in the first triangle. But this is also equal to. So let's make the point at T. Let's say XT and YT. Right? But it'll also be the same ratio, which is YT over RT, which we have as 15. So this would be YT over 15. And all we can do, ladies and gents, is just simply to cross multiply. So YT times 25, that's 25 YT, right? And this is 24 times 15. Times 15, okay, and I can divide by 25 there, and what I do on the left I do on the right. So what's my Y value at T? Right, notice that in this case 5 goes into 15 3 times, and into 25, that's 5 times, okay. So this is going to be 24 times 3 over 5. Okay, yes, they did say without the use of a calculator. Okay, times 3 over 5, but this is just me being lazy. So that's going to be 72 over 5. Okay, so that's 72 over 5. Okay, but we're going to do the same as well for the for the X value. So that means the cos of beta is going to be X over R. Our X value for the bigger triangle, we found that to be -7, okay, over our R is 25. And then on the smaller triangle, our X value is unknown and our Y value is 15. And again, we're going to just simply cross multiply there and say, well, we've got 25x, right, equal to 7 times -15 minus 7 times 15, right? And again, we divide by 25, ladies and gents, and there we go. We've got x is equal to, again, this is going to be 5 and that's going to be 3, right? So that's -7 times 3, which will give me -21 over 5. And so that means that the coordinates of t are equal to, we said, -21 over 5 as well as 72 over 5. All right, and that's how I'm going to leave it there, right? I hope that you were able to follow on. Right, and now the next one, they say to us, determine the value of the following expression. Right, so we're going to simplify that. Right, now the first thing that we always do, ladies and gents, is that you always try to express in terms of cos and sine So what I'm going to do is I'm going to change that 10 squared in the numerator as well as in the denominator to be 1 plus. This is sine squared of x over cos squared of x divide by, this is sine x over cos x. All right, now ladies and gents, I know that there are several ways in which we can do this, right? But what I'm going to do to try and make my working out a little bit simpler, how about, because I see I've got cos squared over there, right? And I've got cos x over here. So if I can multiply both the numerator and the denominator by cos squared of x, right? What I do at the top, I do at the bottom. So this is the same as multiplying by 1, right? So now in the numerator, what do I have? I've got 2 cos x. Actually, I wrote 2 cos x. This is 2 sine x cos x. So this is 2 sine x cos x. Now notice in this case, the cos squared of x plus times 1 will give me cos squared of x, right? Plus, on this one, cos squared of x times sine x over cos squared. Remember, the cos and the cos will cancel. And in this case, I'm left with sine squared of x. Now let's go to the denominator. What do I have on the denominator? This is over 1, right? So that cos cancels out with one of the cos x's. So I'm left with sine x times cos x. Now notice, ladies and gents, that sine x cancels with that cos x cancels with that, right? And what do you notice? We've got a square identity here. Sine squared, cos squared plus sine squared gives us 1. And we've got 2 times 1. And so that will give me 2. Okay, right? Please remember that. Okay, so which means this entire thing just simply gives me 2. Okay, so let's try and get to the next one. Right, I'm just going to remove the previous one. All right. Of course, there were other ways in which you could work this out. Please always remember, ladies and gents, to always convert into sine and cos when you've got 10, right? Now, they say to us, consider 1 minus cos squared of x divided by 4 cos 90 plus a, right? And they say to you, simplify the expression to a single trigonometric ratio. So now we've got 1 minus cos squared of a divided by 4 cos of 90 plus a. So 1 minus cos squared of a will give me sine squared of a, right? We're using our square identity again, right? And again, if you have not watched my videos on proving identities, please have a look at them. Even though they might say grade 12, it is still relevant for you. Right, now we look at this. Cos of 90 plus a. Notice if I say cos of 90 plus, that will change to co-ratio, which is sine. But now how is cos, right? Where is 90 plus a? That's in the second quadrant. So if we use our cast diagram, cos is negative in the second quadrant. So this will be negative, but it changes to co-ratios. So this is right. So that's sine of a. Right. So ladies and gents, all it simply becomes, we've got sine of a, or rather sine squared of a, divided by negative 4 sine of a. Right, the sine a cancels out to one of the sine a's, right? So we are left with negative sine a over 4, or you can say this is negative 1 over 4 times sine A. Right, so this is negative, right? Negative 1 over 4, the sine of A. And that's the most simplest that you can have that expression in. Right, and now they say hence determine the general solution of this entire thing, right? Now, I want you to note, ladies and gents, they actually look exactly the same. The only difference is that instead of A, we've got 2x. And we know that for A, we actually substituted, or we actually simplified that expression to becoming negative 1 over 4 sine A. So what does this mean? It means negative 1 over 4 sine, instead of A, I'm going to have 2x is equal to 0.21. So I'm going to multiply, right, to get rid of the negative 1 over 4. I'm going to multiply by negative 4 over 1. Negative 4 over 1, right? So that cancels with that. So we've got sine of 2x, which is equal to negative 0.84. Right, now we're going to now find the general solution of this and say, well, we've got sine. Okay, now there are two ways in which to do this. We can look at where sine is negative, all right, and you can solve for that. But what I always do is I just look at whatever angle that we have. We are just simply going to say 180 minus. So when it's sine, just simply say 2x is equal to the arc sine of negative 0.84. Okay, so shift the sign of negative 0.84. I get negative 57.14 plus K 360. Right, so that's 2x, where K is an element of integers. But remember, the other solution will be 2x is equal to 180 minus a negative 57.14, right, plus K360. All right, and so we divide everything by 2. So that means that x will be equal to, if I take that value, divide that by 2, that gives me negative 28.57 plus K360. All right, and please remember K is an element of integers. All right, and then we've got the other value, 2x is equal to, so this is going to be 180 plus 57.14, right? And we are going to divide that by 2. Okay, so that gave us 237.14 plus K360. And if we divide by 2, I get 118.57 plus K 180. Actually, I wrote 360 there, but it was supposed to be K 180 because we divided it by 2. Right, and plus K 180, where K is an element of integers. Now remember, ladies and gents, another way that you could have done this is you could have looked at where sine is negative, right? And find the reference angle, right? And you'll see that sine is negative in quadrant number 3 and 4. Okay, so you would have said 180 plus the reference angle and 360 minus the reference angle. That's still the same thing. Okay, you would have gotten to the same answer. All right, ladies and gents, we are going to go on to the next question. I hope that you are able to follow on as well on this one. Question 6, we start. Right, now before we get started, I just wanted to fix something on this. I can see they made a mistake on this graph. Can you see that we've got the values here? We start from 0 now, y values. We've got 2 and then 1. Actually, these should be swapped around. So what we need to do here is that this value here needs to be 1. And that value there is actually 2. Okay. Right, and to verify that that is true, look at this one. This is -1, and 2 steps later, that's going to be -2. So please do note there. All right, so that when we substitute, we can actually get the right thing. Right, now they say to us, determine the value of b. Okay, so we're given in the graph there, f of x is 10 of bx, which is drawn in the interval -90 to 135. All right, now to get the value of b, ladies and gents, I can already see that b is going to be 2. But what we can do to determine that value, we can say, well, let's choose any point, right? And I can choose actually this point here. This would be the point. Notice it is halfway between 0 and 45. So this would be 22.5. Right, and what's the corresponding y value? It is 1. So meaning that 10 of b times 22.5, this will be equal to 1. Okay, so that b of 22.5 or multiplied by 22.5 would be the arctan of 1, which is equal to 45. Right, so now this entire thing gives us 45, and so if we divide by 22.5 on either side, right, you'll notice that we are actually going to get 2 there. So the value of b is actually equal to 2. And how I could see that from inspection is that remember that our asymptotes are usually at 90 degrees, but now they are halfway there. So which means we actually have squished or squeezed the 10 graph into between 180, a period of 180, now to a period of 90 degrees. All right, now let's go to the next one. They say determine the values of x in the interval 0 to 135. And please, if you have not watched my videos on functions, right, trig functions, please have a look at it. It will help you quite a lot. Right, so they say determine the values of x in the interval 0 to 135, for which f of x is less than -1. Now, let's look at our graph. Where is the graph equal to -1? So it's equal to -1 there, and it is equal to -1 there. Now, where is it less than? Right, so this would be less than -1. This would be less than -1, right? So that means our graph would be less than -1 from the asymptote -45 all the way till this point here, which is going to be halfway between 0 and -45. That's -22.5. And again, between 45. Now, what would be 45 plus 22.5? Let's see that. 22.5, that's 67.5, right? Okay, so now that means that it should be less than or equal to -1 between x is an element of. Now note, I'm not going to include -45. Remember, our graph does not or is undefined there, right? Till -22.5. Oh, actually, they said between 0 and 135. Sorry about that. So which means we're only focusing on the positive side. So x is an element of, right? So that's 45 till 67.5, right? So 67.5, we are going to include that because it is equal to 1 there. Another way of writing this, you can actually say x is less than or equal to 67.5, but it is greater than 45. And please note that 45 is not included. So this is essentially another way of writing the same thing. Right, now they say to us, the graph of h is defined as h of x equal to 10b of x plus 55. So what are they doing? They are shifting the graph that we have by 55 degrees to the left. So please remember, when you've got plus there, it means we are shifting it to the left. I know it is counterintuitive, but we are shifting it to the left by 55 degrees, right? Now they say write down the asymptote between negative 90 to 135. So our asymptotes right now are at x is equal to negative 45. Okay, another one is at x is equal to 45. And another asymptote at x is equal to 135. Now remember, what did I say? We are shifting this by 55 degrees to the left. So that's going to be minus 55, and minus 55 of that. Okay, right. So if I look at it, so this is going to be x is equal to, the first asymptote would be at minus, this would be minus 100. But now remember, this is not going to be applicable because we're looking at the interval negative 90, right? So this is not going to be applicable. So we're going to have 45 minus 55. This is going to be negative 10. Okay. And the last one would be x 135 minus 55. So this would be, I think this would be minus 80, isn't it? Minus 80, right? Please just verify that with me. 135 minus 55, definitely that is 80. Actually, I'm not sure why I said minus 80, but it is 80. So x is equals to 80. Now, if we wanted just to check if the other one will fit, right? So look at our asymptotes. The distance between them would actually be 90 degrees, isn't it? So the next one would be at 135 plus 90. Okay, and that should be 225. Okay, so 225 minus 55. Let me just check that. 225 minus 55. That would be at 170. Okay, so it does not actually fit within our restriction. So these are the two asymptotes that will fit within that interval. All right, so I hope that makes sense, ladies and gents. Right, as we swiftly move on to the next one, they say to us in the diagram, we've got g of x, which is cos of x plus 60, which is drawn for the interval negative 150 to 120, right? They say on the same set of x's, draw the graph of k of x, which is minus the sine of x for the interval negative 150 to 120. Show all intercepts with the axes as well as the coordinates of the turning points and endpoints of the graph. All right, so we are looking for the graph of negative sine x. Now notice that the normal graph, the normal sine graph, okay, always starts at 0 and it becomes 1 at 90, it becomes 0 at 180, it becomes negative 1 at 270, and it becomes 0 at 360. So that's what a normal graph would look like. And of course, it would still continue the negative side, right? So this is still going to be 0. Now note, it's going to just be reflected about the x-axis, right? So where it was 1, positive 1, it's going to be negative 1. So I'm expecting a graph that is like this. So I'm going to say, well, I know at 90, so that's 369, so that's going to be at 90 there. My graph would be negative 1. I know at 30 degrees, now you can put that in the calculator. It would be 1 over 2. So now it would be negative 1 over 2. Okay, and I know at 60, it's negative root 3 over 2. Okay. So, and it would be negative root 3 over 2 over there. So this is what my graph would look like. All right, and then I'm going to have the same thing over there. So that would be a half. Okay, that's root 3 over 2 minus root 3 over 2. And that's going to be a half there. Okay, so let's just connect the dots, and that's what our graph would look like. And sorry that my lines are a bit squiggly. Right, so let's just label our turning points first. So I know this is going to be negative 90 and 1. Okay, and I know here I would have negative 150 and 1 over 2. Okay, and they said the intercepts, this would be 0 and 0. Okay, I've got another turning point there at 90 as well as negative 1. And I've got that end point there, which is 120. And this is going to be root 3 over 2. Or you can say, you can find the negative sign of 120, and you'll see that it will give you negative root 3 over 2, negative root 3 over 2. Okay, right, ladies and gents, that's what our graph is going to look like. They say determine the minimum value of cos of x plus 60 minus 3. Now remember, the minimum value was at minus 1, right? That's the minimum value. So what are we doing? We are shifting the graph vertically, right? 3 units down. So if I was at minus 1, if I go down 3 units, right? Where am I going to be? Minus 1 minus 3, which will give us negative 4. So the minimum value will be equal to negative 4. Right, and now they say to us, solve for the equation cos of x plus 60 plus sine of x is equal to 0 for the interval negative 150 to 120. Now, ladies and gents, I'm going to just simply, of course, I mean, we can look at where our graphs intersect each other, but to try and find that value, we're going to now say cos of x plus 60 is equal to negative sine of x, right? So essentially what we are saying is, where is the graph of f of x, where's the graph of k of x equal to g of x, right? Now notice in this case, so we've got sine and cos. Now I'm going to leave this as cos of x plus 60. Now please note this, ladies and gents. How do I change that sine into cos? Right, so in this case, where is sine negative, right? Sine is negative in the third quadrant, right? But it is also negative in the fourth quadrant, right? Now in this case, I'm going to simply say, right, I'm going to make this the cos, so to make it cos, right? So where is cos negative, right? So that we've got cos and cos on this side. Cos is negative in the second quadrant, but I want to use co-ratios. So this is going to be 90 plus x. Do you agree with me that cos of 90 plus x will give me minus sine of x? Definitely that would be true, right? So now, in this case, I've got cos and cos on this side. So I have changed absolutely nothing. So that means x plus 60, right, would be equal to plus or minus. Now remember, when you've got cos, the general solution is 90 plus, plus minus rather, 90 plus plus k 360, where k is an element of integers. Now, of course, we've got x plus 60 equal to 90 plus x, or x plus 60 equal to minus 90 minus x. So in this case, of course, here we'll have no solution. Okay, and so on the other one we've got, right, so if we take the x, it becomes positive. So we've got 2x, right? Please remember this is plus k 360. Right, so we've got 2x is equal to, now if I take the 60 to the other side, it becomes negative. So this is going to be negative 90 minus 60. That will give us minus 150. Okay, this is plus k 360, right? And if we divide by 2 on either side, okay, so x would be equal to negative 75 plus k. Now notice this is going to be k 180, where k is an element of integers. Now remember, they gave us an interval, so we're going to have to find out where is this applicable for the interval minus 150 to 120, right? So now if we say k is 0, right, we're going to have x is equal to negative 75. Right, now if we say k is 1, that would be 180 minus 75. Okay, that gives us 105. Is that still within the interval? Most definitely, right? That's less than 120, so it is still in the interval. Now, if we make k negative 1, we're going to have negative 180 negative 75, which will definitely give us something that is outside of the interval. So we've got those two solutions, which are negative 75 and 105. And you can see that there were 2 points where actually these graphs intersect. So which means this one must be at negative 75 and this one must actually be at 105. Right, and so that's our solution there. That means x is equal to 75, negative 75, as well as 105. All right. Now they say determine the values of x for which the for the interval rather negative 150 to 120, for which the graph of g of x, right? So if I take that to the other side, so this would be cos of x plus 60 greater than negative sine x. So this is where the graph of g of x is greater than the graph of k of x. So where are the graphs above each other, right? Or rather, where is the graph of g, which is the original graph that was given to me, right? Above the graph of k. Now, I want you to note it is above, right? So there it is over there. Okay, until they intersect there. So from where they intersect again until where they intersect. So in this case, we said this is minus 75 and this goes all the way to 105. So I am going to say for this solution, x is an element of negative 75. Okay, so this is not included because they're equal there. So this would be negative 75 to 105, and that's going to be excluded as well because they are equal. Otherwise, alternatively, right, we could say that x is greater than negative 75 and less than 105. All right, and now we go to the very last one. Okay, if you don't mind, I'm just going to remove all of this so that it's easier for us to solve. All right, so the last question, they say to us, the function g can also be defined as y is equal to minus the sine of x minus theta where theta is an acute angle, determine the value of theta. Now, remember that the graph of G is y is equal to the cos of x plus 60. So that's x plus 60. Now, ladies and gents, I want you to note, they are telling us about negative the sign of something, right? So what I'm going to do is to convert cos into sine. What we simply do is that we just say this is 90 minus, okay? So I'm going to say, well, this is the same as sine of 90 minus x plus 60. Now you agree with me, if I say 90 minus anything, that will give me cos, right? And so as a result, what do I have? I've got the sine of, right, so I've got 90 minus 60, right? If I multiply by that negative, so that makes this 90 minus x minus 60. So 90 minus 60 gives me 30, right? So that would be 30 minus x. Now remember, I wanted it to be x minus something, right? And so this will be the same as minus the sine of x minus 30. All right. And so that means that theta, notice there, theta will be equal to 30 degrees. And they did say that it is an acute angle, so theta will be equal to 30. All right, ladies and gents, I know that functions can really be quite a bit of work. All right, so please, if you have not watched my videos on functions, even if they say grade 12, please remember that it is the same thing as the grade 11 content. All right, so let's move on to the next question. Question 7, they say in the diagram we've got PR is the diameter of the circle. So triangle PQR is drawn with vertex Q. Okay, so there's vertex Q over there. Okay, and they say outside the circle, and they say R is theta, PQ and QR are 2y, and PQ is y. They say determine the value of cos theta. Now notice this is not a 90-degree triangle. However, the angle theta, right, would be the included angle between the two sides PR as well as QR, right? So we're going to apply our cos rule there, right? So remember, there's our other side. So we're going to apply our cos rule. Now remember, we know that on the in the cos rule, we're going to say the length of QR, the side opposite that, that angle. So we just simply say PQ. So remember, PQ squared is equal to the two sides, which is QR squared, plus the other side, that's PR squared, minus 2 times QR, it's the same sides, times PR, the cos of the angle R, the angle opposite to the side that we're looking for, which is theta in this case. Now, all we simply do is we're going to put the size of that, so that's going to be y squared. That's going to be QR is 2y. Okay, so that's 2y squared plus another 2y squared minus 2 times 2y and 2y. And this is the cos of the angle theta. All right, now let's try and do our gymnastics mathematically. So that's 2y squared, which is 4y squared, plus another 4y squared. That will give us 8y squared when we add them up, right? So this is going to be another 2 times 2 times 2, which is another 8y squared cos of theta. And this gives us y squared. Now if I take that to the other side, ladies and gents, so we'll have y squared minus 8y squared, which will give us minus 7y squared, which is negative 8y squared. Okay, the cos of theta. And of course, we can divide both sides by -1. All right, now I am going to divide both sides by 8y squared. 8y squared. That cancels with that. And so the cos of theta, they said they wanted the value of theta. So cos of theta is equal to, now we're left with 7/8, right? So that is the value of cos of theta. It is equal to 7/8. Okay, right. Now they say to us, if QR cuts the circumference of the circle at T, so where's QR? All right, so cuts the circumference of the circle at T. All right, and so that should be T there. And they say determine PT in terms of y and theta. So they want us to find out what PT will be. All right, so let's try and draw this nicely. So PT is that guy over there. All right, now notice in this case that PR, they did say that that is a diameter. So what does that make PT and TR? They are perpendicular to each other, and this is angles at semicircle, isn't it? Okay, so in this case, we can apply our trig ratios and say, well, look, we are looking for PT, which is opposite that angle, but we do have the hypotenuse. Now, PR becomes our hypotenuse in that case. So that means that what is opposite over hypotenuse? That's going to be the sine, right? So I'm going to say in triangle PTR, right? So the sine of theta will be opposite, which is PT, over hypotenuse, which is PR. And so what that simply means, remember we are looking for the line PT, so which means that PT will be PR. Now remember that PR is, okay, so let me just write it first. The sine of theta, and PR is 2y, right? So that will be 2y, the sine of theta. Now remember, in fact, I think I was meant to mention that PT is, or rather angle PTR. Okay, angle PTR, okay, equals to 90. And this is angle at semicircle. Okay, right. That is it. And hopefully that makes sense to all of us, ladies and gents. Right, let's go swiftly to the next one. 8, they say a cylindrical aerosol can has a lid in the shape of a hemisphere that fits exactly on the top of the can. The height of the can is 16 centimeters. The radius of the base of the can is 2.9 centimeters. Right, so they give us the volume of a sphere is 4/3 pi r cubed, and the surface area of a sphere is 4 pi r squared. Okay, right, now they say to us calculate the surface area of the can with the lid in place as shown in figure 1. Now remember, the surface area of this can is first of all going to be the area of the circle, right, underneath. Okay, so let's try and draw this just a little bit more nicer. Okay, so it's going to be the circle, which is the base. Okay, and it is going to also be the surface area of the surroundings of the can, right? And then we're going to take the surface area of the lid, right? So let's say, so for 8.1, I'm going to have, first of all, the total surface area. Okay, we're going to have pi r squared. Remember, that is the circle, which is the base, right? Plus, now notice, ladies and gents, when we take the surface area of a cylinder, right, it is always going to be the circumference of the circle, all right, circumference of, or rather the base, okay, or the perimeter of the base multiplied by the height. Okay, right, so in this case, we know that the circumference of the circle is 2 pi r multiplied by the height. So this will be plus 2 pi r, okay, times h, right, which is the height of the cylinder, right? This is plus. Now remember, the surface area of this, or of a sphere, is 4 pi r squared. But remember, this is a hemisphere, right? In this case, this is just a half of a sphere. So this means that we will divide that by 2, right? Now 4 over 2 gives us 2. So that will be 2 pi r squared. Now let's add all of that up. I've got like terms. Pi r squared plus 2 pi r squared will give me 3 pi r squared. Okay, plus, in this case, I've got 2 pi r h, and that's 2 pi r h. Right, so we can now substitute for what we know, right? So this is 3 pi. Now remember, radius, they said it is 2.9 squared plus 2 pi, that's 2.9, and they said the height is 16. So let's find out what that surface area is. Okay, so I'm going to say 3 pi times 2.9 squared plus, that's going to be 2, and this is pi, okay, times 2.9 times 16. Right, so we get 370.80. Okay, so that's the total surface area. And notice this was given to us in centimeters, was it? Right, this was definitely centimeters. So this is going to be centimeters squared. Okay, right, so that is how we're going to get the total surface area. And then the last question on this section, they say if the lid is 80% filled with liquid, as shown in figure 2, calculate the volume of the liquid in the lid. Now, the total volume of the lid, okay, 8.2. So the total volume of the lid in this case will be 4 over 3 pi r cubed. This is the volume of a sphere, by the way. But remember, we have a hemisphere, right? So this is going to be a half of this because we're looking at only one thing, right? One side. So the volume will be 1 over 2 multiplied by 4 over 3 pi r cubed, right? So that would be the volume of that hemisphere, the total volume, right? So this is going to be 1 over 2 times 4 over 3. Actually, let's just multiply that out. So this would be 4 over 6 pi r. But remember, our r value, okay, is 2.6. This is cubed. Okay, so this would be now the volume if it was full, right? So what I'm going to do there is I'm going to say this is 4 over 6 multiplied by pi times 2.6. That's cubed. Okay, I get 36.81, right? Centimeters cubed. But remember, this is 80%. So that means that the volume of the liquid would be 80 over 100. That's 80%. Or you can say 0.8 times that volume of the liquid, which is 36.81. Okay, so I'm just simply going to take that value and multiply it by 0.8. Okay, and I get a value of 29.45 cubic centimeters. And really that is how we're going to answer that, ladies and gents. And essentially that finishes this section. And let's go now into the next section, which is trigonometry, geometry. Question 9, they say give reasons for your statements and calculations in question 9, 10, and 11. Right, so they say in the diagram we've got O, which is the center, okay, and we've got diameter LR. So notice the fact that they say to us this is a diameter, right, already tells us that this angle here must be equal to 90 degrees, right? So that would be the angle at semicircle. Now that means that LKR must be a 90 degree triangle, and we can actually find this angle R here. Right, now let's not get ahead of ourselves. They say N is another point on the circumference, and chord LN and KN are drawn, and L1 is 58. Now, of course, what would this make angle LRK? This angle here, this would be 32 degrees, right? If you consider that these are angles on a triangle, L1 plus K plus R. But it means that angle R would be equal to angle N. So these are both 32 degrees. These are angles at same segment, right? Okay, so I want us to quickly have a look at what they're asking us there. They say calculate, giving reasons, the size of LKR. So we're looking at that guy here, LKR. That's K1 and K2. So we're simply going to say LKR is equal to 90 degrees. And what's the reason there? We say this is angle at semicircle, right? So okay, let's write that. Okay, so angle at semicircle. All right, we know that angles at semicircle are equal to 90 degrees, right? And then they wanted angle R. So we're going to say, well, angle R would be equal to 180 minus 90 plus 58. Okay. And so that gives us 32. And why is that? These are sum of angles in a triangle, right? So angles in a triangle. All right, and then what about angle N? We know that angle N is equal to angle R, which is also equal to 32 degrees. And we say that these are angles at same segment. Okay. All right, and that's how we're going to answer question 9. All right, as we go on to question 10. 10, they say in the diagram, O is the center of the circle. Now, ladies and gents, I did say that whenever we see the center, always try and identify your radii, right? So I can see that I've got OC, I've got OA as well as OB. All of those are radii, and we know that our radii are equal. Now, they say to us, it is the center of the circle, right? A, B, and C are points on the circumference of the circle, right? Chords AC and BC and radii AO, BOC, and CO are drawn. They say A is equal to X, right? And B is equal to Y. Now, please let's note in this case, before I even go as far as answering the question, so what this simply means is that angle C1 must also be equal to x. And why is that? Because in this case, OC is equal to OA, and so that makes angle OAC an isosceles triangle, and we know that angles that are opposite equal sides on an isosceles triangle are also equal. But what does that mean? It means that also angle C2 will be equal to y, right? And in this case, it means that angle B would be equal to C2, and it is exactly for the same reason. Right, now let's go to the next question, or rather, let's go to the question. They say determine the size of O1, right, in terms of x. Now, firstly, let's deal with that angle there. So 10.1.1. So we said, firstly, that C1, okay, in fact, let's start with OA is equal to OC, and these are radii. And we know that, therefore, it means that C1 would be equal to angle A, which is equal to x, right? And what would be the reason there? We say angles opposite equal sides. Or you can actually say that, this is base angles on an isosceles triangle, right? And so that means that if I look at O1, O1 would be equal to angle A plus angle C1, right, which is x plus x. This is equal to 2x. So the value of O1 is 2x, but why is that? It is the exterior angle on a triangle. Right. Now, they say to us, apologies there, they say, hence, prove the theorem that states that the angle subtended by an arc at the center is equal to twice the angle subtended by the same arc at the circumference. So they're simply saying prove that angle at center is equal to 2 times angle at circumference. Now we've already proven that O1 is equal to 2x. In the same way, let's find the value of O2. So we're going to say O2, all right? In fact, once again, we're going to say, well, it means that OB is equal to OC, and these are radii, okay? So that's 10.1.2, right? So that means that angle C2 is equal to angle B, right? And these are equal to y, and these are, and the reason for that is that these are angles opposite equal sides. Okay, now please, I want you to note, ladies and gents, that means for the same reason, angle O2 will be equal to C2 plus B, which is equal to 2y. Okay, so it will be y plus y, which is equal to 2y. Right, now what I want us to note, ladies and gents, if I look at angle ACB, right? So ACB, angle ACB is equal to x plus y, right? And let's look at AOB. AOB, right? This is equal to, now please, I want you to note, it is equal to O1 plus O2, right? And what's the value of O1? It is 2x. And what's the value of O2? O2 is 2y. So now it means that if I look at AOB, right, this is equal to 2 times x plus y, but you notice x plus y is ACB, right? So it is 2 times angle ACB. All right, so we have now proven it, that angle at center is twice angle at circumference. All right, ladies and gents, as we move on to the next question. Now they say to us in the diagram, we've got PQ, which is a common chord. Okay, so there's our PQ there. Okay, so it is a chord in both circles. Right, I know I've marked it in black there. Maybe let's just change the color. Okay, there it is. Right, now it is a chord in both circles. Right, so they say to us the center M. Now remember, I said to you, the moment that they tell me about my center, what I quickly want to go and see is whether I do have radii. So I do have radii MQ as well as radii MP, right? And I want you to note, ladies and gents, that both those are in the larger circle, the bigger circle. They are radii in the bigger circle, right? Okay, so that definitely makes angle P2 equal to Q1. So I can already indicate there that this would be equal to X. Right, now they say to me, right, so they say PMNQ is a cyclic quad. Very important there. PMNQ, where is that? So PMNQ, I'm going to just indicate it there. So PMNQ. So it is a cyclic quad in the smaller triangle, right? So this guy is a cyclic quad. Very important for us to note, okay? And they say QN is produced to R. Now remember, ladies and gents, when they say to us something is produced, it means it makes a straight line. And what that simply means is that you might need to look at angles on a straight line, exterior angles of a triangle, exterior angles of a cyclic quad as well. Okay, so now we are going to, they say QN is produced to R, a point on the large circle NM, right? And in this case, they say produced, NM produced meets the chord PR at S. Okay, so once again, PSR is a straight line. They say P2 is equal to X. Right, now, let's try to see which other angles can we find out that would be equal to X, right? So firstly, I can see that Q1 would be equal to X. I did say that because triangle PMQ is an isosceles triangle. But I want you to note, it means that N2 is also equal to X. Why is that? It is an exterior angle of a triangle, isn't it? So in this case, it means that that guy is also equal to X. All right. Is there any other angle either equal to X or related to X? Well, just something to note there. I can see that N1 would be 180 minus X, right? Okay, so we can try and find as many of them as possible. But that means that if you look at this angle here, right, it's in the triangle, right? So this would be 180 minus 2x, okay? So that would be 180 minus 2x. Let me not create the impression that they are equal, right? So that would be 180 minus 2x. So now look at this. What does that make this angle over here, right? I wanted to use a different color. This angle over here becomes half of that angle. Remember, angle at center is equal to twice angle at circumference. So this guy, if that's 180 minus 2x, this will be 90 minus x. All right, so let's quickly have a look at this. Right, so they said give a reason why n2 is equal to x. Right, so why is n2 equal to x? All right, so I'm just trying to change the color of that there. So n2 is equal to x, right? What is the reason there? Right, we said exterior angle of a cyclic quad. Okay. All right, so it is equal to x because it is an exterior angle of a cyclic quad. Now they say to you, write down another angle equal to x and give a reason. We've already found it. Okay, we said this guy here is equal to x, q1. So we're going to say, well, for 10.2.1, so q1 would be equal to, let's say q1 is equals to p2. Okay, angle q1 is equals to angle p2, which is equal to x. And we said, why is that? Because these are angles opposite equal sides. Okay, and by the way, we do note that MP is equals to MQ because they are radii. Right, now they say determine the size of R in terms of X. Right, now what we did, ladies and gents, was to say, well, we know what the size of M1 is. So I'm going to answer it over there. So 10.2.3, right? We said M1, angle M1 is equal to 180 minus P2 plus Q1, right? And why is that? These are angles on a, or rather in a triangle, right? Sum of angles, or you can say interior angles on a triangle, angles in a triangle there. So that means that M1 would be equal to 180 minus 2x, okay? Right, so it is that angle there. So now that means that if I look at angle R, now note in this case, it means that, in fact, let's write it this way first. So M1 is equal to 2 times angle R, right? And the reason for that is that angle at center equal to 2 times angle at circumference. Okay, now if you note this, so that means that angle R rather will be M1 divided by 2, which is 90 minus x. So 180 minus 2x divided by 2 will give us 90 minus x. And that's what we get for angle R. All right, so we found this guy here, which is 90 minus x. Now they say prove that PS is equals to SR. Right, now they want us to prove that PS, which is this guy, is equal to SR, which is this guy here. Now remember, we can use, in this case, our theorem 1, right? Or the converse of theorem 1. And if we can prove that angle S2 is equal to 90, right? We know that line drawn from center, if it is perpendicular to a chord, then it bisects the chord, right? So then what I'm going to do, ladies and gents, I'm going to simply say, well, let's find out the angle S2. Now note, we know this guy is 90 minus x. What would be the value of S2? Now note, in triangle NSR, all right, I can see that the sum of angles on a triangle, so that means that N2 plus angle R plus angle S2 are equal to 180. So then it means that if we take S2, oh, by the way, I need to state the reason for that. These are interior angles in a triangle. All right. So now I know that S2, okay, angle S2 will be 180 minus 90 minus x plus x. Okay, so look at this, that cancels with that. I'm left with 180 minus 90, which is equal to 90 degrees. There it is, ladies and gents. We've proven that that is a 90-degree angle. And so as a result, we know now that it means that, therefore, PS is equal to SR, right? And why is that? Line drawn from center, right, is perpendicular to the chord. Okay. So line drawn from center is perpendicular to the chord. All right, so there it is, ladies and gents. We have proven it. Okay, and that is the end of question 10. Now we're going to hop on to question 11. We look at question 11, right? We are concluding this paper. It says in the diagram, the vertices A, B, and C of triangle ABC are concyclic. So meaning that they are actually touching the circumference of a circle. They say to us EB and EC are tangents, right, to the circle at B and C respectively. T is a point. Now remember, once you've got tangents, in this case, there I've got my tangent, and they are tangents from the same point. Remember that tangents from the same point are equal. Right, so please keep that in mind. So T is a point on AB such that TE is parallel to AC, and they say BC cuts TE at F. Now, they say prove that B1 is equal to T3. Now, ladies and gents, what I always like doing on these type of questions is, let me just first identify, let me find an angle and let me call it X and find out how many other angles I can relate to X or make equal to X. So if I took C3, for instance, right? C3, this guy is equal to X. So because BEC is already an isosceles triangle, what does that mean? It means that B1 would be equal to X, right? These are angles opposite equal sides. Okay, we know that's an isosceles triangle. But notice in this case, once again, we've got the 10 chord theorem as well, right? So there's my chord, the angle opposite that chord. So that means this would be equal to X. A will be equal to X in this case. But please note, it means that also T3 will be equal to X, right? And the reason for that is that they are corresponding angles with A. All right, so there it is there. It is a corresponding angles. They are corresponding angles. Okay, so now we've already proven that B1 is equal to T3. Let's just write it in this case more systematically. So we said, well, B1, first of all, is equal to, now if you note there, that B1 is equal to angle A, right? And this is the 10 chord theorem. Okay, so there's B1. Okay, there's our tangent. There's the chord. Angle opposite that chord would be A, right? And now we said that angle A must be equal to angle T3, right? And we said these are corresponding angles, right? So we must keep in mind that they told us that TE is parallel to AC. Okay, right, and so therefore it means that B1 must therefore be equal to T3. There we go, ladies and gents, and they say prove that TBEC is a cyclic quad. I can already see how I am going to prove that. All right, so remember we found that C3 was equal to T3, isn't it? Right, but how did we get C3 to be equal? Well, we said B1. Okay, in fact, let's start here. Let's say BE is equal to CE. These are tangents from the same point, right? Okay, so tangents from the same point. And so we note in this case that it means that B1 is going to be equal to C3, right? And note in this case, we say these are angles opposite equal sides. Okay, so angles opposite equal sides. Another way you could have also said C3 is equal to A. That's the 10 chord theorem again, right? So you could have used that as well. So now, because we realize that T3, right, we've already found that B1 is equal to T3. So in this case, B1 again is equals to C3. So therefore, it means that C3 would be therefore equal to T3, right? Okay, and so we've proven. So therefore, in this case, it means that TB EC is a cyclic quad. All right, and please state the reason. And what is that reason? Because in this case, we have proven that the angles that are on the same segment are equal. So converse of angles at same segment. Okay, right, we've proven that angles at the same segment are equal. So in this case, it means that that must be a cyclic quad. And please remember, once I've proven that it's a cyclic quad, it means that I can use the properties of a cyclic quad, right? So they say prove that ET bisects BTC. So there is BTC. Okay. Now, if ET bisects, it means that angle must also be X. Very simple to prove. We have now proven that that is a cyclic quad. And please note, what it means is that B1 is now equal to T2. So B1 would be equal to T2. But why is that? Because these are angles on the same segment. So these are angles at same segment. Okay. All right. And so that means that T2 is equal to T3, right? Remember, we had proven that T3 is actually equal to X. And so what it means is that this guy would also be X. So therefore, it means that ET bisects, okay, BTC. All right, ladies and gents, I hope that you are still following. Right, now let's now reach, some conclusion. So they say if it is given that TB is a tangent to the circle through B, F, and E, right? So there's TB. Okay, let me try and remove all of this. So there's TB. They say it is a tangent to the circle that passes through B, F, and E. So let's imagine that there's a circle here. All right. Now, if that line is a tangent to that circle, what it simply means is that we can apply the 10 chord theorem. So that means that B2 should be equal to E2, right? So now they said we must prove that TB equals to TC. Now, ladies and gents, we want to prove TB equal to TC. So if we can prove that this angle B2 is equal to C2. And I can already see how we can do that. So for 11.4, now notice, it means that B2 would be equal to E2, okay? That would be the 10-chord theorem, all right? But note that E2 is equal to, so E2 would be equal to C2. These are angles at same segment. Okay, right, so these are angles at same segment. So now what does it mean? It means that B2 is equal to, so therefore it means that B2 is equal to C2. Now note, now we can apply in this case. We say, well, these are lines opposite equal angles, right? So these are sides opposite. Actually, I needed to have stated there. So therefore what it means is that TB would be equal to TC, and these are sides opposite equal angles. All right, so that's an isosceles triangle there. Now they say to us, hence prove that T is the center of the circle through A, B, and C. Now this becomes really easy, right? If we move from T and we go to the circumference B, but we move from T and we go to the circumference C, we've just proven that those two sides are equal, so therefore they must be radii, right? They are from a certain point in the circle to the circumference, so therefore it means that T must be the center. So we've just proven that TB is equal to TC, right? So we've proven that. Okay, so now therefore it means that TB and TC must be therefore radii, right? Since they're inside the circle. And so therefore it means that T is the center. Okay? Right. Because they are sides from the same point to the circumference. Okay. So these are sides from same point to the circumference. All right, and ladies and gents, essentially this is how we are going to conclude this question paper, really worth 150 marks at the end, right? And I hope that you are able to follow on in every single thing that we do. Right, and for those of you that still require help with grade 11 content, please note that our sessions are available. We've got Saturday sessions, we've got weekly sessions. We also have a center, right, where you can register. All the details that you require will be on the WhatsApp group that is on the description of this video. Ladies and gents, I will see you guys next time. I hope that you have a awesome day going further. All right, see you guys next time. Sharp, sharp.